Hello boys and girls, this is Mr. Song and here's the answer for number 37 on the homework from last night. So it says find the functions f of g, g of f of f, and g of g and their domains. So here's f of x plus 2 over 2x plus 1, and g of x, that's equal to x over x minus 2. And domain of f is any number that's not negative 1/2, because when x is negative 1/2, your denominator of f is 0 and you can't have that. And the domain of g is then any number that's not 2. Okay, so let's start with f of g. What is f of g? I am going to look at f because g is going inside, so you can think of it as f of g of x this way, right? So any number, or any time you see x in your original f of x, I'm going to put a bracket. Plus 2 over 2 bracket plus 1. And instead of x, I'm going to plug in the function g of x. X over x minus 2 and x over x minus 2. So hopefully this is not the hard part, or this wasn't the part that you were struggling with. It must have been the algebra. So let's look at this. There's a fraction plus a constant over a fraction plus a constant, and I'm assuming it's the fraction part that's troubling you. So let's get rid of this fraction and make it a non-fraction. So what do I need? I need to get rid of this x minus 2, so I'm going to multiply the top, or the numerator, by x minus 2. And I have to do the same to the bottom, or the denominator. Okay? Notice that whatever I'm multiplying here on this right side is 1, because x minus 2 over x minus 2 is 1. Okay? So now I am going to multiply this x minus 2 on top to the numerator. But we have x over x minus 2 plus 2, so you have to distribute. This goes here, and this goes to 2. Okay? Then what do I get? X over x minus 2 times x minus 2. The x minus 2's will simplify, and you have x left, plus 2 times x minus 2 is 2 times x minus 2. You see how easy that was? Now you don't have a fraction, right? I'm going to do the same thing to the denominator. This x minus 2 here is going to be distributed, so I'm going to multiply this to the first term and the second term. So here we get, well, 2x can just stay, 2x plus 1 times x minus 2. Okay? So we have x plus 2x minus 4 over 2x plus x minus 2. And finally, our f of g of x is equal to 3x minus 4 over 3x minus 2. Now let's think about the domain of this new function, our composite function. What would it be? Well, remember this was a composite function and g of x went inside of f of x, so you have to carry the domain of the inside function. And if you go back up here, we already talked about the domain of g, that was x is not equal to 2. So if you just look at this expression, when x is 2, it's okay, but you have to remember that this was a composite function and carry the restrictive part of the input inside function. So x cannot be 2. And now let's look at the composite function. So this is a rational function, so again, you cannot have a denominator equal to 0, so x cannot be positive 2 over 3. Because when x is 2 over 3, then 2 over 3 times 3 is 2, 2 minus 2 is 0, then you can't have that. So there is f of g. Let's do the same thing for g of f. Now if you watched that first part and now you know how to do it, then pause this video and try g of f on your own. Yeah, and you can check to make sure that you're doing it right. That would be a great idea. All right, So I'm going to do the same thing that I did earlier. I'm going to look at g, the original g, and that's x over x minus 2, right? And now I'm going to plug in what f is. So here is x minus 2, or x plus 2 over 2x plus 1, x plus 2 over 2x plus 1. I'm just going to check to make sure that was the correct f. There you go. And I have this. This is at least what you should get at first. Okay, and again, I have a fraction over a fraction, and I don't like it, so I'm going to get rid of it. How am I going to do that? Well, the denominator of the upper part, or the numerator, is 2x plus 1. So if I multiply this by 2x plus 1, I can get rid of this bottom part. But I'm going to do that the same thing to the bottom, and notice I am multiplying by 1, and in the numerator I get x plus 2. In the denominator I get x plus 2 minus 2 times 2x plus 1. Now remember, you still have to distribute, right? So this 2x plus 1 is being multiplied to x plus 2 over 2x plus 1, and you have to multiply to minus 2. Okay, then here you get x plus 2 in the numerator. In the denominator you get x plus 2 minus 4x minus 2, which is then x plus 2 over negative 3x plus 0, or negative 3x. There are many ways to write this. Because there are no terms here, you can write negative x plus 2 over 3x. You can leave it exactly how it was. I don't know how the solution gave you the answer. They could have also done negative x plus 2 over 3x. These are all okay. Let's expand the page a little bit. Alright, so that was g of f. So g of f of x is, let's use this one, middle one, negative x plus 2 over 3x. Alright, what is the domain of this? Remember that f was the inside function, so you have to carry the domain of the inside function, which was x cannot be negative 1/2. Okay, and look at this one. This is our composite function, and x cannot be 0. So there's your domain. X is any number except negative 2 or 0. Okay, now let's do f of f. This is quite interesting because you're putting a function, the same function, in a function. So what does that look like? F of f. Okay, so the f was x plus 2 over 2x plus 1. So x plus 2 over 2x plus 1, and inside I'm going to put f again. X plus 2 over 2x plus 1, x plus 2 over 2x plus 1. Now I'm going to get rid of the fraction over fraction business, and I'm going to do that by multiplying by 1. But a very clever form of 1 that's going to do what I want it to do. So 2x plus 1 over 2x plus 1. Notice the top and bottom of the fraction is the same, so that's 1. I'm going to multiply this numerator to the top part of the original function and denominator to the bottom part. But again, I'm going to distribute this over to the first term, the x plus 2 over 2x plus 1, and to 2. So what do I get? I get x plus 2. Okay, the 2x plus 1's cancel out, plus 2 times 2x plus 1 over, on the bottom part, I'm going to do the same thing. This gets distributed here and here. I get 2 times x plus 2, because that 2 and x plus 2 here, plus 1 times x, 2x plus 1. There, I just have to simplify. X plus 2, and then there's a 4x here, so 5x, and that's a 2, so plus 4. We can simplify here as well. So that's 4x, and there's 2 times 2, which is 4, plus 1 is 5. Okay, so that's f of f. Okay, let's look at the domain. Uh-oh, I put f of g instead by mistake. F of f. Okay, what was the inside function? That's f. Okay, so what was the domain of f? X is not equal to negative 1/2. What is the domain of the composite function f of f? X is not equal to negative 5/4. And there is your f of f, and here is the domain of f of f. There's one last question, g of g. Okay, what would g of g look like? That's a g. Okay, g is x over x minus 2, so x over x minus 2, and I'm going to plug in g inside. Whenever there was an x, I'm going to write x over x minus 2, x over x minus 2, right? And I'm going to do the exact same thing. I'm going to multiply by x minus 2 over x minus 2, right? So the top part, x over x minus 2 times x minus 2 is just x. And here, because of the minus 2, you have to distribute this x minus 2 to the first term, and the second term. So here I get x minus 2 times x minus 2, and you get x over negative x plus 4. Sometimes people don't like putting a negative in front, so they'll say 4 minus x. That's okay too. 4 minus x. But you can leave it like this. I'll leave it like that. X over negative x plus 4. And let's think of a domain. Domain of this is g had a domain x is not equal to 2. Any real number except x equals 2, and the composite g of g, x cannot be 4. So that's your domain of g of g. Okay, hope this helped. Do your homework.